Hi there, and welcome to my channel. In this problem, we are given that a particle moving along the curve in the xy plane is at position x of t, y of t, which is a parametric function of time, at time greater than 0. And the particle moves in such a way that the derivative of x with respect to time is equal to the square root of 1 plus t squared, and the derivative of y with respect to time is equal to natural log of 2 plus t squared. And we are also given that at time t equals 4, the particle is at the point 1, 5. And the first question is to find the slope of the line tangent to the path of the particle at time t equals 4. And so what is the slope? The slope is the derivative of x of y with respect to x. So it's dy over dx at that point. And this is equal to dy over dt over dx over dt. And so we need to plug in the values for t equals 4 into the expression of dy dt and dx dt and calculate that. So dy over dx at point t equals 4 is equal to dy over dt at t equals 4 over dx over dt at t equals 4. Let's plug in those values here. We get ln 2 plus 4 squared over square root of 1 plus 4 squared. And this is equal to ln of 18 over the square root of 17. And so we need a calculator to calculate that, but this is a pretty straightforward calculation, so I will not be showing it. And this is equal to 0.701. And so this is the answer to this question A. Let's move on to question B. In this question, we need to find the speed of the particle at time t equals 4 and find the acceleration vector of the particle at time t equals 4. And so let's recall that the speed of the particle in the parametric form is given by this expression, which is the square root of the derivative of x with respect to time squared plus the derivative of y with respect to time squared. And so then the speed at time t equals 4 is equal to, we need to plug these expression into the functional form for dx dt and dy dt. And we just had those calculated, square root of 17 plus ln of 18 squared. And so we can pull our calculators and calculate that, but this is pretty straightforward. I will not be showing it how to do that. And the answer here is 5.035. So that's the answer for the speed at time t equals 4. And now let's find the acceleration vector. And acceleration vector at time t is equal to the vector of the second derivative of x with respect to time and the second derivative of y with respect to time. And it's a vector, so it's two separate accelerations along the x-axis and along the y-axis. And so let's calculate the derivative of x with respect to time. That's the derivative d over dt of dx dt, which is the square root of 1 plus t squared. And this is equal to 1/2 square root of 1 plus t squared times the derivative of 1 plus t squared. This is chain rule times 2t. And so dx d2x over dt squared at t equals 4 is equal to 8 over 2 square root of 17. And again, this is pretty straightforward calculation on a calculator. And this is equal to 0.970. And let's calculate the second derivative of y with respect to dt. And this is equal to d over dt of the second derivative of the first derivative ln2 plus t squared, which is equal to derivative of natural log is 1 over, so this will be 1 over 2 plus t squared times the derivative of 2 plus t squared, which is 2t. So in this case, d2y over dt squared at times equals 4 is equal to plugging it in 8 over 18. So this is equal to 4 over 9. And again, using the calculator, we can calculate this to be 0.444. And so the answer here is that a of 4 is equal to a of 4 is equal to 0.970 and 0.444. This is the answer as well. And so let's move on to question C. In this question, we need to find the y-coordinate of the particle's position at time t equals 6. And recall from the fundamental theorem of calculus that y at time 6 is equal to y at time 4 plus the integral from 4 to 6 of dy over dt. So the general form will be f of b equals f of a plus integral from a to b of f prime of x dx. And so in our case, we have plugging in the dy dt here and y at of 4, which is given to us, which is 5. So let's plug in the values. We get y of 6 is equal to y of 4 is 5 plus integral from 4 to 6 natural log of 2 plus t squared dt. And so let's pull out our calculators and calculate that. So let's calculate y of 6, and this is equal to 5 plus the integral from 4 to 6 of the function dy over dx, which is natural log of 2 plus x squared. And I'm using x, it doesn't matter. Instead of t, it's just a variable. And so let's solve this. And the answer is 11.570. So the answer is 11.570. So as we just calculated, this is equal to 11.570. And so this is the answer for the position of the particle, y-coordinate of the particle at time t equals 6. Let's move on to question D. In this question, we need to find the total distance that this particle travels along the curve from time t equals 4 to time t equals 6. And so let's recall that the distance is given by the traveled by an object between the time t1 and t2 is given by the speed as a function of time dt. So in our case, this distance is equal to integral from 4 to 6, and the speed we calculated before is equal to the square root of 1 plus t squared plus ln 2 plus t squared dt. And let's pull out our calculators and calculate that. So let's calculate this distance, and for that we need to calculate the integral from 4 to 6 of the speed, which is the square root of dx dt squared, which is 1 plus x squared plus the square of dy dt squared, which is natural log of 2 plus x squared, close parentheses, close another parenthesis squared, and then this is with respect to x. Enter. And so the answer is 12.136. The answer is 12.136. And so as we just calculated, the answer here is 12.136. So the distance that the particle traveled is 12.136. Thank you for watching. If you like this video, please don't forget to click the like button and write me your comment below, and subscribe to my channel where you can find more solutions to the AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.